Yo. Yeah, I can hear myself delayed. No, I don't hear it twice. I don't hear you twice. I just hear myself on the TV like a minute later, or more like 10 seconds later.
So, can you still hear me, Marty? Mark, you should be able to join the voice chat. I'm probably going to have to work on my overlays a little bit here because we're adding the Discord into the live stream as well as Twitch and YouTube. Okay, it looks like Restream is reading Discord, but I hear myself twice. That's not fun. All right, Marty, how do I stop monitoring myself? Here. Off. Is that it? Oh, there we go. All right. Marty, let me see if I can hear you again. Crap, I can't hear you. What else can we do? Input, output device. All right. How about now? Nope. That's not doing it. Mark, you figure out how to jump in and connect with the voice as well? Then I don't always have to look at the chat window. Should be able to pull everybody in. Oh, well, everyone can chat in Discord. I can see it that way, but I don't know how to get it so that I can hear you. Try one more thing here. No idea, can't hear anyone. I can't hear anyone either. Set that back to there. And add my overlays. Add desktop audio as a source. Input capture. Nope. Hold on. Add audio output capture. Desktop audio. Oop. I got something. Okay, we got background music. Let me turn that off. And Marty, I hear you now.
Can you hear me now?
Yep, I hear you now. Awesome. I don't know if this is going to get too crazy with so many audio streams patched together, but I don't know. We'll give it a try, right? See if this works. Okay. That should be persistent all the time. Cool. Now let me get rid of my important private screens. I need to hide all my stuff here so I can switch over to my desktop. Desktop. Sweet. And it looks like I have some of the overlays working.
Carbon Fury, hey.
Ooh, I heard that. Carbon Fury, what's up, man? I haven't seen you in a long time, my friend. I can't wait till we can find time to get together here. I don't know, I'm gonna end up missing the at Parker's Playground in April. I'll be running the race at Alfred State. Let's see. Okay, so anyways, King of Hearts quad. Let's pull that up and let's kind of run through it real quick and figure out where we left off. Here's our live stream quad number 1. Let's see. Can't find that. Where'd my network go? Uh-oh. I'll be entering that over there. Uh-oh. I got cameras everywhere in here. Let's see. Oop. Yeah, there we go. Yeah, there we go. All right. Let's find my DYS 1407 motors that we had stuck onto this thing. Drones, FPV. I don't know where those motors are. Oh well. Let's see if it reads the rest of the Okay, there's our King of Hearts quad. And I've been working and failing at those booties there, but I finally made some progress. And so I'll walk you through what we did this week. And everything we did so far on these little protectors is thanks to Lone Star figuring out the post for my CNC machine and why I was having some difficulties. So I went through and found a post file, and what a post file is it takes the program that you wrote in the CAM software and translates that into G code that's going to work for your CNC machine, right? So your post has to know exactly what your machine has on it and what it's capable of. It does all the translation and it generates the G code file. And G code file is what you load up in the controller and you run that file to make your part. The 3D printers work the same way. Like if you're using Cura, Cura basically handles the post. You go into Cura and you select your 3D printer from a list of 3D printers, or you have to make a custom 3D printer. And basically what you're doing is instructing the Cura's like built-in post processor what to do when it generates the G code. So post is short for post processor. And I was having difficulty, and I've been working around it for however many years I've owned that machine. And finally, Lone Star pointed out that all my problems would probably be solved if my post was using 4 decimal places instead of 3. And so I fixed that, and wouldn't you know, my CNC machine is working way better, and I don't have any circle errors anymore. Even the sound of the machine is different. So yeah, thanks. Shout out to Lone Star for that one. That was pretty big. So here, let's see, we're making these little corner protectors, and we're gonna make these out of a real soft durometer urethane. And we decided that we're going to do like a silicone mold so that we can show the process of machining out like a hard tool in order to cast our silicone into. And then the silicone, once that's dry, will be used to cast the urethane parts. It's similar to what we did when we built the pods for the raggy frames, except we used a 3D print instead of hard tooling on the CNC machine, right? So we printed out the raggy pod on the 3D printer, and we had to sand it, finish it, paint it, and put some texture on the thing. And then we did a 2-part silicone mold of those. And then Smarky's over there at his place pounding out canopies for raggy out of nice like durable urethane resin. And we're kind of do the same thing with this booty here. And so we made this form here, which has our 4 corner protectors in it. And we're going to machine out this pocket so that we've got a solid chunk of tooling, and we machine in here, and all we're left with is these 4 little corner protectors. And then in this pocket, we're going to pour some silicone, and that's that right there. So we'll pour silicone into there, and then when that sets up, we'll have our mold, right? So there, that would be our silicone there. And if we open this part up, that would be the piece of silicone that we're left with, right? And you've got cavities that we just are going to fill with our urethane. And because this silicone is nice and soft, then we just peel it away, pop out our little corner protectors. And that's the idea. But the CNC machine's been fighting me on making the first half of the mold here. And so after the third try, we finally got it. And let's see if we can pull up some video and we can walk through where we are now. Booty mold. So this is the King of Hearts booty here. Alright. Got some audio coming through for our video. Yep. Okay, cool. Alright. So there she is, sitting on the shop saver. This is attempt number 2, and it didn't work until attempt number 3 because still had a problem in the new post processor that I didn't catch, and so I made a mess on the first attempt and had to go in and fix it. And now that I have that fixed, everything is working good, at least until I find the next problem in the process. So there we go. So I loaded up my this is like a 3-inch half-inch end mill, 3 flute, a real low helix. It's good for doing these tooling foams. Removes a lot of material really fast. If I had a bigger machine, you could really haul with that cutter. Right now what I'm doing is setting the origin on this piece of material, and all I did was screw this block down into the foil board, the sheet of MDF on there. It's sacrificial, so like you could see, you could see a couple screws in the corners. There's like I don't know, like 6 screws in each corner, just holding that piece there. And this is like also known as butterboard. It's the softest cooling board. I think it's something like 10 pound density per square foot or something like that. It's super lightweight, and you can see later when I screwed up and I sent a cutter at like full depth, full speed through this board, and it didn't care. The machine didn't even slow down. So it's a good board for making mistakes in. Even though it is a little expensive, it's a good board for making mistakes in. So where are we at? Okay, so we're zeroed out, brushing off some of the crap, and we're gonna fire up. And this is gonna be operation 1. It's a roughing operation to remove the majority of the material very quickly, right? So there, I turn the speed down to 10,000 RPMs. That's as slow as that router head will go. Because the idea here is you wanna form a chip and not make super fine powdery dust. So I've got the speed turned all the way down, RPM wise, and my feeds are as fast as I feel comfortable. Right, so there we're helixing down into the material, and then she's just gonna run around like a, I don't know, like 70 or 80% step over. So really quickly we get a huge pocket. Okay. I just cut after that roughing operation. Here we loaded up our 1/4-inch cutter. Little 2 flute end mill, 1/4-inch, and there's the problem right there. So the cutter is going down, 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 and it's now like 1 inch or 1 1/4 inches deep into the material and wandering around in there. And there, I finally caught it, hit the E-stop, and swore a couple times, and went back to the drawing board. Okay, so here we are. I fixed the code. What the code was doing was it was changing my work offsets in each operation, and so it like moved my whole Z height down like 2 inches, and I didn't catch it until that cutter was buried in there. Had this been a denser material or aluminum, that cutter just would have broke right off, and that would have been expensive mistake. It was still an expensive mistake because that this butter board is expensive, and that's why I'm using every single scrap that I can. I save every piece, just because this stuff's so darn expensive. You know, even the lower density boards that are cheaper, they end up being expensive just because they're so big. You pay a lot to ship them, and anyway, all around expensive stuff. So here we go. Picking a new origin. Basically, we're just moving over like 5 inches, and we're gonna repeat the whole thing again. And I'm in there double checking the code, making sure that that one line is deleted out of there that was giving me problems. And so here we go, fire it up again. You'll see me, I'm pulling the switch on my router head. This machine has spindle control on it, but for whatever reason, the solenoid, no, relay, yeah, the solid state relay that turns the router head on does not work properly with the soft start feature on the quarter cable. So on the old spindle it worked fine, but on this spindle with the soft start, there's some sort of problem where there's no load on the motor, so it won't turn on unless I throw the switch. It'll turn off. The software can turn the thing off again, but something doesn't turn on. I need to like put like something stupid like a light bulb, you know, wired into the circuit so that there's like some sort of load there. So there we go. See, just in a few seconds you got that whole pocket roughed out. That's the purpose of this pass here. Now what she's doing is going and just roughing out the material that's around those our little King of Heart booties here. So right now that's just like 1/4 of an inch deep. If I had a faster machine, you could really fly through this stuff because you'd see it's still kind of making dust. Although I don't know if that material will chip up because it's such a low density stuff. What we got? I think we're leaving like 50 thousandths of material all around our parts, so we're not getting too close to the final part with that roughing operation. We're gonna clean up the rest of the material when I switch over to that 1/4 inch cutter. I think the bonus to using the super lightweight foam is that it has a porous texture to it, and so when we cast our silicone into there, the silicone's going to pick up that it's going to pick up the texture of the foam, and we should have like a really nice like spark erosion like texture on our parts for free, basically. You know, we don't have to like hone them or glass bead them or anything. They should have a nice matte finish with just a real fine texture on them. Hopefully. We'll see if that's true. So here we are with a 1/4 inch cutter, and you can see I'm cutting a whole bunch of air. But for the life of me, I could not figure out how to get rid of that really high feed plane in Mastercam, and I was spending more time trying to chase down a fix than I was saving myself, you know, because we're only making one mold, So I might have saved myself like, I don't know, 2 or 3 minutes in machining time. But I was like 20 minutes in trying to figure out why the feed plane was so high. So sometimes you just have to be smart about where you're spending your time. There was no reason to keep chasing it down. If you were going to be making 1,000 of these, then you would spend all day trying to figure out why that was cutting so much air up there before it engages in. I want to say that it has something to do with, I could force it into that pocket with a containment feature, but I don't know, not too important. That's what fast forward buttons are for. But anyways, the advantage to CNC machining this is that we don't have to do any finishing work to the part. So, like, you know, Marky and I have spent some time together at the table with sandpaper and primer, finishing the 3D prints, trying to, you know, bury all the lines and stuff like that. And so here we get a part finish right off the CNC machine that doesn't need any like secondary operation. And let's see, this video is 17 minutes long. So I want to say that our machine time was around like 15 minutes. So 15 minutes would be a pretty small part on a 3D printer. This would probably be several hours to try to print this out, and then on top of that, you'd have several hours into sanding. So that's why, like, I'm opting to go with the CNC machine for this. All right, so this is like your final pass. A finish pass, taking off the final like 20 thousandths of material. I'm being like real gentle with the part because the foam is delicate and I don't want to snap off these real thin features out here. I'm surprised I didn't. The way my luck has been going on this project, I thought for sure I was going to be breaking something else, but they machine pretty good. Their cutter comes around, does its finishing pass, and the next thing we do is we load up our spot drill, and the spot drill has like a 90-degree tip on it, and that's going to allow me to chamfer those edges with a 45-degree angle. There she is, our spot drill is just going around, putting in the chamfers. And you can see that I'm chamfering a pocket that's not there yet. And I was just doing that in case I had to do a collet change. I wanted to use all my 1/4-inch tools before I went down my 16th-inch tool. Here's my 16th-inch end mill, and that's going to go in and do the final pockets. All right, so too small for that 1/4-inch end mill to fit in there. Here we go. Those are our like M2 clearance holes for our motor, and a clearance hole for the bearings and the C-clip that stick out of the back of the motor. You see, it did a roughing pass, and then here it is doing a finish pass, taking off that last like 20 thousandths. I don't know if it's clear enough on the stream, but you can kind of see the texture on the parts when it's zoomed in like this. It's a real light foam. It's like a kind of a porous material. We're zoomed in pretty good here, so it's a pretty fine texture. Like those holes there that we're drilling are 2 millimeters across. And that end mill there is a 1/16 of an inch. I'm cutting those holes, these pockets right now, as deep as I can with that cutter. That way the silicone will end up sticking out higher than my part, and I think you'll see what I mean by that when we start casting the parts. It means if I overfill the mold urethane, or if like there's a meniscus or whatever and the urethane is sitting kind of high, these little pockets are going to allow the silicone to go even higher. Should allow me to make the parts cleaner. There we go. Walk around here. It is. So finally, success. Lone Star's got my post all figured out. The machine's happy. Machine sounds better. So there they are. Looking good. Super delicate. Watch me break one of these things accidentally. All right, so that was over at the shop, and now we're into pouring our silicone. So out of the shop and over to my my workshop here. So there's our tooling board, and here's what we got. Mixing cups, our gram scale, part A, part B, that's our Mold Max 30 silicone. Super soft silicone, same silicone that we've been using to make the raggy pods with. And the 30, that I believe refers also to the durometer. It's like a 30A, Shore 30A durometer material when it's fully cured. And this material takes a full 24 hours for this stuff to set up. Super slow to set up, but what's nice about the slow setup time is that you've got plenty of time for the air bubbles and stuff to rise to the surface, which makes it not as necessary to vacuum degas the material after you mix it. So when you mix these two parts together and stir them, introduce air into it, and those air bubbles end up getting trapped all over the place. But that real slow cure time allows those things to rise to the top, and they usually don't end up sticking to your part. So I got a little post-it note with me for the ratio that we got to mix this thing in. So it's a 10-to-1 by weight mixing ratio, and if I pause this, I can come over to SolidWorks and show you how we come up with that. So here's what I intend to make out of silicone, right? And so I'm going to come in here and evaluate this part in SolidWorks. SolidWorks is going to tell me that this thing weighs 208 grams. You do have to define the density of the material. So if you go to Smooth-On's website, and you can look up the Mold Max 30, and I have entered a material here. So I've defined this as silicone rubber, and I have the density filled out in SolidWorks so that SolidWorks knows how to do the calculation correctly, right? So I can rely on that. 208 grams, that's what our finished part's going to be. You want to mix more than 208 grams because you're going to lose material in the mixing cups and on the stir stick. So about 10% of your material is going to stick to the cups and the stir sticks, So you go about 10% over, and that's safe. So I'm taking the 208 grams, and because it's a 10-to-1 mixture, all I'm doing is adding 20.8 grams of hardener to 208 grams of silicone, and that's how I'm coming up with my final. Pull that camera. There we go. So that's how I'm coming up with my weights. So I'm going to 208 grams of part A, our resin, silicone itself. I'm going to go to 20.8 grams part B, hardener. Hardener, catalyst, whatever you want to call it. This is a tin cure silicone, not a platinum cure silicone. For those of you who are interested in what type of silicone it is, you can see how crazy thick this stuff is. It's pretty ridiculous to work with. And the uncured silicone that's in that tub, it has a way of getting on everything and not coming off, like, ever. Like, it makes things like super slippery, right? It's silicone. If you ever walked into like auto body shop with this this bucket here, or some of this schmoo on your hands, they would likely murder you. Because if that started getting all over a paint shop, paint wouldn't stick to cars anymore in that shop. It'd be horrible. There. You can kind of see that I already have air bubbles in there just from stirring that stuff up in the bucket. Anyways, some of the air bubbles come out when you're pouring it. Go. You guys are quiet in the chat tonight. Either that or I've broken it and nothing's functioning anymore. Checking my side window. Alright. Trying to cut off the flow because I'm getting really close to my number there. There's some technique there.
Tulsaland's paying attention.
Thanks for paying attention, Digital Silence. Awful, nasty, sticky stuff. Horrible. Horrible. And the other thing that was horrible when I was filming this was that there's mosquitoes out. It's been winter every day up until like this morning. Now it's warmer, and when I shot this today, there's mosquitoes like flying around my face the whole time. So here we go, part B. What's going to harden the mixture and give it its pink color. This they recommend that you shake the contents of this stuff. The silicone, that's okay to shake. The urethane, not okay to shake. If you were to shake the urethane, never get the bubbles back out of it. So urethane is stir only. Silicone, you stir the resin and you shake the hardener. Oh, I should put a camera on the scale. That way everyone can know that I accidentally went over by like a half a gram right there. There we go. Now we combine the two. would have been a little easier if I would have chose a slightly larger mixing cup. So what I'm doing is I'm taking care to try not to mix too much air into the silicone when you're blending these together. And you want to like bring the material up from the bottom. And you want to scrape the material off the walls of the cup. Or mosquitoes. It was crazy today. You could feel the warm air like rolling into Boston. It's crazy. I don't know what it swung like 20 degrees. I stepped out of the shop and it hit me. Like it was probably 10-15 degrees colder in the shop than it was outside. Oh, there. You see, I'm getting all that stuff scraped off the walls, and now I'm going to transfer that mix over to the other cup, and that'll pick up the rest of the hardener that's stuck to the walls of that cup. And if you wanted to, you could go back and forth a couple times if you wanted to. The pot life on the silicone is like a couple hours, so you got plenty of time to work with this stuff. And if you're vacuum degassing, plenty of time to vacuum degas. So when I say that, what you would do is put the after you're done mixing here, and you've mixed a whole bunch of air into there, you throw that into the vacuum chamber, and you'd pull it down to as low as you can get with your vacuum pump, and you got to get pretty low. Not like a shop vac vacuum. You have to have a real pump that can get you down to like, I don't know, 29 inches of mercury or something like that. So close to perfect vacuum. And then that'll pull the air out of your mixture. You also have to have a really big mixing cup when you do that, because it's going to rise like bread, like dough. All those air bubbles expand, and so your mixture, it like doubles or triples in size when you pull vacuum, and then it collapses, right? All the bubbles expand, and finally they pop. The whole mixture like collapses in on itself. Then you know you're good. You can release the vacuum, let the air back into the chamber, and pour your silicone. I don't have a vacuum pump. I've got a two-stage Venturi pump, which works pretty good. It gets rid of the air quickly, but it just goes low enough. It doesn't go super low, but it just goes low enough to pull air out of this stuff. And it's a lot cheaper than the electric vacuum pump. Here we are, pouring the silicone in. What you do is you start from one corner of the mold, and you go real slow, because you want the silicone to flow into all those little holes and pockets that we've got machined in there. You don't want to trap air in those pockets. If you just dumped it all in there super quick, all it would do is trap air in everywhere. So here we are. We just start in one corner. I actually have a paint stick underneath it, so that it's not level right now. Yeah, you're just letting the silicone flow nice and slow across there. And you can see that the air bubbles are starting to come to the surface. Some of them you can see popping as they're going across and they stretch. That's the idea. Try to pour it gently so that you're not trapping additional air. Pouring.
Yum.
Get this guy some Pepto-Bismol, right? It's either Pepto-Bismol or it's the pink slime from Ghostbusters 2. Except the pink slime from Ghostbusters 2 had that nice like metallic flake mixed in. Made it look super delicious. Actually, strawberry yogurt. This could just be strawberry yogurt that I'm pouring in here. I brought this mold inside, so this has to stay at like 70 degrees in order to cure properly. I got it in the house right now. And tomorrow afternoon, it'll be ready for me to pop that silicone out. And hopefully it comes out. It wouldn't be the first time I glued something together. In general, the silicone doesn't stick to anything but itself. So you're usually safe when you're pouring the silicone. When you do the urethane, you absolutely 100% have to make sure that you put mold release on everything you're doing, because the urethane is glue. The Gorilla Glue is just urethane. So if you don't put mold release in there, you pour urethane into that pocket, that'd be it. You'd be done. You would have just made a big... You basically would have filled the hole. You could start over again. You could put it right back on the ZZ machine and machine right into it. There she is. So, she'll be ready tomorrow. We can start making some King of Hearts booties, our corner protectors. I figure we should volunteer Smarky. I'll give him the silicone, and while he's over there making raggy canopies, he can pour a little extra something into our booty mold here. He doesn't know that yet, does he? He's not in the stream tonight. Maybe we should let him know that he's got some work ahead of him. So anyways, you saw me pounding on the mold there. So I was just banging on it for a little bit, trying to get any air that's trapped down next to the parts. Just trying to release any air bubbles. Otherwise, when you go to cast your urethane, you'll have little like knobs. Anywhere there was an air bubble, it'll be a little knob hanging off your part. Oh, Smarky. Live stream. Alright. That's it for our silicone molding session. Delta 5 enclosure that we're working on. There. Let's see. Pop over here to Mastercam. Okay. There's our cam program for this guy. Let's see. There's the tool path for that roughing operation. And here's the cleanup afterwards. You can see those really tall helixes that I couldn't get rid of. There. And then our finishing operation. And then we have our chamfer. 4, and then our final little pockets there. That's it. So with the proper machine, you can see how fast it should have taken. Let's see our info. So 7 minutes it should have been. 7 minutes 14 seconds. That was our our program length. Now, my machine took more like 15 minutes, and that's just because my controller is not a really high-end controller. So there's a lot of wasted time in there where it's not going around corners as fast as it could, and it's not doing rapids as fast as it could. There you have it. I think the next part that we had to work on was our battery strap thing. Now that I know that the CNC machine can do all this stuff, do I want to make that? Nope. No, I want a 3D print. That's the crazy part. Oh, what else do we have? I think that might be pretty good on there. I think we're looking pretty good. What's chat say? Am I missing anything on this guy? Other than putting it together? Maybe we can start another project here. Time to start.
Tram thumbs up sign.
Thumbs up from Marty there. I don't think we're missing too much, right? Pretty solid build. Yeah. Oh, let's see. Finish up our assembly, make sure everything's present and accounted for. Let's see. I'm just gonna add these to the file here. Okay. Clearly I have a problem with that mirror operation. Okay. Booty. Nope. 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 Oh. Yep. I'm a dummy. That can't go there. Neither can that for that. Alright. Starting over. Get rid of this. Right. That goes over there. No. We can do a mirror operation just to generate a right and the left hand part. Okay, so I'm going to make a second part here. My mirror by saying create opposite hand version. There we go. Okay, so that these two are not a common part. They can't be shared. So now we have a right and a left version of that part. And then if I reorder these operations, I should be able to mirror these back successfully. Nope, that was wrong. Wrong. That would have to be a rotation, not a mirror operation. So I need axes, axis to rotate around, and a circular pattern. Pattern these around that. There we go. That's proper. Okay. Now we dive into our toolbox and we can start putting our screws and stuff in. Go into our metric screws, bolts, hex heads, socket heads. Now we can start throwing our motor screws in. And nice little thing, you get a little drop down box. It recognizes the size of the hole as being a clearance hole for 2mm, so it auto selects to M2. All I got to do is tell it how long I want it, and I can change to a wireframe view, and I can pull this guy into the motor. So 8mm, 6mm, 6mm doesn't quite do it. 8mm is all the way through the aluminum and not into our windings, right? I don't know if you can kind of make out what's going on here, but we've got our windings right here, and this is the gap between the kind of the base of the motor and the bell housing, right? And our screws end right there. If we use an 8mm, so that is perfect. Yes, that's good. And you can either go around and click every single hole, or because this is a whole feature, we can say feature driven pattern. I want to pattern this, and I want to pattern it with those holes. And I need to skip one, that one. Wanted to, we could add those to our mirror operations. So I'm going to go into my mirror, add all those screws into the mirror. Now they'll show up on this side of the quad. And then I'll edit our next one. Oh. Oh. That's so. Yeah, I'm selecting my screws that I want to mirror. To the back of the quad. There we go. So this is going to get us to a more realistic weight here. We got some screws up here to put in. Those in there. That should find that it's an M3. Yes. Yes, it did. M3. And our length. Let's see. 8mm again. Perfect. Oh. Pop that one over there. Good. All right, where else do we need some screws? Hide this battery because I think there's some screws that need to go under here. Let's see, we've got our screws for our stack, but we don't have any screws going into our camera mount. That. Drag our countersink over. Oh, grab the hole. Try that again. Go. Does not recognize that hole size. Ooh. M2 is not available as countersunk screw. Oh my. That's no fun. Why you no fun? Alright, we'll just leave those out. Throw our little M2 in there. I'm just trying to get the weight as realistic as possible by throwing these screws in here, right? So if we're piling in all these steel screws, we kind of want to know what this is going to weigh. 4mm probably good. Those ones have to be nice and short because if you go in too far, you end up hitting important parts. I'm sure a couple people in the group that could tell us all about running screws into the sides of the boards in there. I don't think they're designed like that anymore. I think they finally changed those to blind hole, or maybe they don't hit anything. Screws used to be lined up with right with that circuit board. Man, if you put the wrong screw in there, drove it right into the side and split that circuit board, and no more work. All right, I'm not too worried about much else. Drag one of these standoffs over here. Attach it to that screw.
Fender, yet it's blind now.
It's blind? Oh. That was nice of them to change that. I'm surprised they even changed that. They probably sold so many extra cameras for that. So this would be like a regular 6mm standoff. That kind of works. No, maybe these should be nuts. I'm gonna make this a new part by saying make independent, and I'll change this to 2mm, which is I think what a nut is. So that'd be like one of those little nylon standoff nuts that comes in those kits. And we'll put our other one over here. We'll also put the other one right there. We can kind of use the nut as a standoff. Good enough. You're going. Plenty of room. Just checking. Still don't have a battery strap modeled, but we've got a 1,000 mAh 4-cell battery strap to the bottom of this. What are we coming in at? 280 grams. 281. So as long as we can lose some weight in real life with screws and a little bit smaller battery, this would certainly work as probably a pretty decent mini freestyle quad and a sub 250 racer.
Jervon Haas, hello.
Hey, what's up, Haas? Thanks for popping in. We're almost done with our little stream quad. There she is, our 4-inch 250 class King of Hearts live stream quad.
Quest_FPVO.
Hey, Quest, what's up? Oh man, everybody's here now.
Hossman.
Can you guys hear the program reading all that stuff back?
Fender, I dropped about 15 grams changing from steel to aluminium screws on my 3.
15 grams. Steel
Quest_FPV, yup.
Is that annoying or is that okay to have the text to speech? I think I want to leave it because now that I'm monitoring that channel, nice. I don't have to keep my eyes on my second monitor. It looks like it'll read everybody. It's reading Discord. It's reading, let's see, Fender is over in Discord. It's reading him.
FPV, I like it.
It's reading Quest over at Twitch. It's reading Quest over on
FPV,
YouTube.
nice
Cool. Yeah, man. Is this the first time you've seen the King of Hearts quest? I don't know. Did I post it? Did I post a picture of it? If I didn't, I probably should. I don't know if I did or not. I have a close-up, I think, on my Instagram, right? I have a
Quest _FPV. Yes, this is the first time.
First time you're seeing it? Okay. Maybe we should do a little render. Post this in Facebook. Let's line this up here. We'll do a real dirty render. Real dirty in
Quest _FPV
render.
as complete as this is now.
Oh, is it? Yeah. Okay. Were you in earlier when I was showing CNC machining the tooling board and pouring the silicone and all that stuff? Under here.
Quest _FPV. I miss it. Can I watch it back?
The Twitch saves the videos for 14 days, and YouTube keeps them forever. I've got it DVRing. But let's see. We'll probably pull it right up. Oh, the render thing in this thing is terrible. It's no good. Quest, don't look. Don't look, Quest. Hey, it's got some ambient occlusion in it. It's got that going for it. Alright, I'm not gonna post that back in the group. That looks terrible. I'm gonna turn that off now. That was no good. Alright, we'll have to make it pretty and stuff like that in order to do a rendering. We need to do something proper. Actually, I'd probably just export this out into Fusion, because Fusion's pretty easy to do a decent render. Although I don't know, if I spend the time assigning all the proper materials to this thing, the normal render engine in SolidWorks does a fine job. But I don't know, I've been using Fusion a little bit more often for rendering, just because it's quicker. It seems to be quicker to set up materials. They got a huge material library built into the thing, and a pretty solid render engine behind it. I'm not sure which engine is rolled into it. I doubt it's their own, scratch built
Quest
thing.
_FPV. Haha, you need Vray. Tulzalin's screenshot. Post.
V-Ray Quest, huh? I don't know. I don't know. Sell me on V-Ray Quest. I kind of liked Arnold. It was close to Mental Ray, because back in the day that's what I used all the time. I was always using Mental Ray, because the final gather, right? That was back in the day when most of the stuff was just like ray traced and there's no ambient occlusion on anything. So I would always go right to Mental Ray, so you can do all that, whatever I just said. You get the ambient occlusion with the final gather that was built in the Mental Ray, right? And then, then that went away most recent time that I pulled up Maya, right? And it seemed like they were going with Arnold. And it was a pretty easy transition over to Arnold from Mental Ray. I had to watch a couple of YouTube videos when I got, couldn't find the right, variable or something like that. But V-Ray, I don't know much about V-Ray. You'd have to sell me on V-Ray. I see that you were doing the Brain FPV logo, right? Rendered out in V-Ray. Like I saw that go by on your Instagram. I'm curious. I want to see that. I'm gonna end up throwing you the Bando logo.
Quest_FPV Arnold is pretty easy to use. I like it too. Check out the new Brain FPV logo. I used V-Ray. It looks pretty simple. Quest_FPV, yes.
Oh. I'll have to audit one of your classes. Are you still teaching?
Quest_FPV. Wow, this lags in the chat a bit.
Yeah? How long's the delay? I hope it's not too long. I know there's a little delay because I'm DVR.
Teach Agent this fall the Arnold class.
That's cool. That's cool, Quest. I should do it again as well. It'd be cooler to get paid, right? Let's save this up. What else we got going on? Our Delta 5 enclosure. Oh, I could fire up. Let's roll that video back a little bit. Anyways, this is for the guys that just kind of popped in. And I'll just kind of fast forward. This little piece of that urethane board, some Wren shape or whatever, butter board, like 10-pound density, super light stuff. And we're just making making the tool so I can pour some silicone in order to do our little corner protectors there. Right. Working on these little corner protectors. That'll be a soft urethane. So there we are. This is attempt number 2, which ended in failure. And we'll fast forward to attempt number 3. Lone Star had to help me straighten out my post-processor. Here we go. There we are. On the shop saber, hogging out some of that tooling board. This is our roughing pass for that pocket. With like it's a 1/2-inch 3-flute low helix end mill. Yeah, and it's doing what it's made for. It's made for these foam boards. And it's got like a 3-inch cut length on it, so it's made to get into these molds and stuff like that. Let's see. Fast forward to there. So I'll finish up roughing. Here we come in with 1/4 inch. And this is the rest machining, so it's cleaning up all the material that the 1/2-inch cutter can't get to. And after it does that cleanup, then it goes back and does a finish pass. Right, so right now there's like 20 thou of material around the part for safety. And then she comes back. There, so there's our finishing pass. That cleans up. The roughing operation is faster, so it leaves little scallops behind. And the finishing operation a little bit slower. Get a finer surface finish. After we do our finish pass, then we change out for a spot drill and put a chamfer on the part. There's a spot drill running around doing the chamfer, doing its thing there. I was really surprised that it didn't break those corners off. I thought for sure that's where I was going to fail. after I straightened the post out, I thought for sure I was going to break these little pieces off because this foam is super, super light. There's nothing to it right there. But no, we hammered around. The spindle's full out at like 23,000 RPM. And I feeding around 40, 50 inches a minute. And then come back in with 1/16 end mill and doing the final pockets there. So putting in the screw holes, putting in the clearance hole for the bearings, and putting those little like shock absorbing pockets in there.
Quest_FPV looks thin. Guys at work will fill in the outside with clay to work the insides.
I'd love to see all the things that they do over there. Yeah, so they probably would machine a lot of material away, right? So that less than your part would be left, right? And then come back in and coat it, right? Coat it with a layer of clay and then remachine it to its final dimension. You know, if we're talking about the same thing, I think that's what we're talking about, right? So you'd use your foam to get your basic shape and structure, use your cheaper, lighter material, right? And then
Quest_FPV.
Yeah, okay, yep. So you would actually remove more material than your final part. Then you come back in and put this like half-inch layer of clay down on top of the foam, and then you go back in and you machine the final part. So you get the high quality surface from the clay, and yet you don't have this like 2,000 pound block of high density urethane. Yeah, that's cool stuff. There we are. There's our little finished parts. This like 10-pound foam is kind of porous, so I'm hoping that it leaves a really cool texture when we cast the parts, you know, like a sandblasted texture for free. And then after that, back to the old shop, and we're mixing up some Mold Max 30, smooth on some silicone. And there we go. 10-to-1 by weight. Look at how thick that stuff is. Nice gooey schmoo. It's not sticky, it's like slippery. Gets on everything. Horrible. Once it's mixed, you can get it on anything because then it just peels right off when it's dry. But the unmixed stuff, it's terrible. It's impossible to clean off of whatever you get it on. Go. Part A, part B, 10-to-1. There. Mixed together. Need better lighting in my my shop. It's all coming from one direction. It's funky. Transferring it back and forth to the two cups so that you can kind of get all the material off the walls and stuff. Good and mixed. Scraping it off the walls. And where do we pour? There we go. Pour. No degassing for me. Pouring it in, air bubbles and all. So you tip the material a little bit and you start in the lowest corner and you just go nice and slow. And hopefully the material floats into all the little holes without trapping any air. Goes nice and slow. And you stay in that corner and you just let the material roll over the top of all the parts. Then when you're done, beat the crap out of it to try to get some air out. Slap it around. Little slap and pickle. So I did that this afternoon, so tomorrow I'll be able to peel that little guy out of there. Send that over to Smarky. Get some booties made up. And then I think the carbon fiber is sitting over at the racetrack, but I do have the little acrylic one over here that we cut out on the laser. So this was like our prototype. Blasted it on the laser to like check the fit. Not that I had to. I just wanted to demonstrate using the laser. So there she is. Be a cool quad. Screen on you. Yeah. King of Hearts. Oh, that's the other project that we started. Calm down. That we started last week was our timer box for our Delta 5. So, if you guys, the rest of you guys saw this, but there she is. Our Delta 5, our first Delta 5 timer. Oh, she's stuck. There we go. So, there's a 6-node timer. Started. Got our Raspberry Pi and our boards from Scott Chin, RX 5808 receivers,
TV cool.
and a whole bunch of Arduino Nanos. So this is number 1, and we've bought parts to make 5 more of these guys. I'm not crazy so far about the tuning. We're kind of spoiled because the first timer we bought was the immersion timer, the 8-way, and that thing is so solid and so easy to tune. Once Scully shows you like what the 2 values do, it's a piece of cake. This thing, the Delta 5, is more like a auto tune type thing. First person to go over the top of it kind of sets the threshold, and so that makes me a little bit nervous. I don't have any real world testing on it yet. Marty and I were just over at the track, like screwing around with a tiny whoop, and it functions, works, but I don't know how it works with a race with a bunch of people yet. So I don't know. We'll see. This is going to be like our split time, so I'll be able to see like who's in first place, like on all corners of the track once we get a whole bunch of these made up, and also I can see how fast you guys are going. So once we have multiple timers, we can start tracking speed just by measuring the distance between the timers. So that'd be cool. I don't know. We were throwing the tiny whoop around like 20 miles an hour. I don't know. We'll see. It'll be cool. I don't know. So I'm trying to come up with a box here. This will house the timer. I really want to try running aluminum on that chop saber, especially because watching who's got one? Who's been building that? Did it start off as a shape? What the heck is it called? I've been following it and following him, and I don't even know. Can't even tell you anything about it. He's been upgrading his like desktop CNC. He's got like new linear rails on it, new spindle, a new top. So now he's got like a ground aluminum plate on the thing. He's doing a really good job, and I'm jealous because it looks really cool. And he's making aluminum parts on it, making big aluminum parts on this little desktop CNC. So I really want to get the shop saber cut in aluminum. I know what my main problem is, right? You can go slow, you can take tiny cuts, right, in order to work within your machine's limitations. Because I've got big stepper motors, right? They're big, but they're still stepper motors, and it doesn't take too much to miss a step. So anyways, small depth of cut, don't take too much material, and I should be able to do it. The problem is the spoil board. The MDF spoil board, it moves too much, and that's where a lot of the like chatter comes from, and it's bad enough to like break the bits. So I've run sheets of aluminum before on the guy, and it's not great. So I got to get that fixed. I got to like replace the tabletop on the machine with like a piece of phenolic or one of those aluminum plates. I looked up like I can get like a 1-inch thick aluminum plate for the top of the machine for a reasonable amount of money, right? A few hundred, several $100s, which for a CNC machine, that's not a lot of money. Just about every part on these machines gets into four digits, but I figured an aluminum top, or maybe half the table aluminum, like the first 2 feet aluminum, and then the back 2 feet can be just regular MDF spoil board. But just something that when I put when I clamp down, it'll be more rigid. MDF it just gives too much. Anyways, I wonder, was it like, it wasn't Nicky Nito, right? Was he the one building up that desktop CNC? I don't know. I had to run through my Instagram real quick and see who's been working on that thing. I don't want to spend too much time around looking for it. But you guys should check it out because, I mean, it was super legit, right? What the heck is that new one? Isn't it orange or something like that? I keep thinking Shapeways, but I think Shapeways is the website where you can like get 3D printing done, right? That's all that's stuck in my head, and I can't think of anything else. Is it a Shapeways CNC? Bother me that I can't remember now. Somebody's gonna have to stop me because I'm stuck in it.
Quest_FPV ya not Shapeways.
Not Shapeways. What on earth is the name of that CNC then? Isn't it Shape something? Ah. Well, that stinks. I give him a little bit of credit for working on building that machine like that. That was pretty impressive. Anyway.
Kram Nitram, is it the Stepcraft?
Stepcraft. You got it, Marty. Thanks, Marty. Marty always knows. He doesn't even know what I'm talking about. Right? You don't follow that guy, that drone guy that's upgrading his Stepcraft, right? Stepcraft. Yeah, that's it. There we go. These guys.
Kram
Was it the
Nitram,
orange
no,
that gave it away?
I don't watch him.
You said orange? Yeah,
You said
perfect.
orange.
Yep. Yeah, so this is what the guy started with, I believe. I believe. I'm not sure what, These aren't too bad for price. Black edition. Desktop system. So anyways, yeah, little desktop printer. And maybe that's not what he started with. I don't know. Anyways, it's basically home built at this point. Everything on it was upgraded. And he got it to the point where he could make aluminum very slowly. And so started
Quest_FPV solid CNC.
making brackets and stuff like that, making all the upgrade parts. And eventually got to the point where it's basically no longer Stepcraft. It's his own machine at this point. I don't know. Maybe the boards is like the only thing left on it. All been upgraded. But it's super legit now, right? Because he's got like a, I don't know, half-inch or so aluminum plate bed, and a whole bunch of quarter 20 holes all over it so that he can clamp and fixture real easy. But yeah, and he's running. He's got coolant on the thing, and he's got the nicer like water cooled spindle, and yeah, now he's running these aluminum parts, and the finish on them looks really legit, considering that it's like a desktop type setup. They're not all chowdered up. They're close to mirror finish on his parts. It's impressive. Big fan. Makes me jealous. Marty, we need to take the desktop CNC that's in the trailer and like get that thing up and running super legit, right? I think all that thing needs is
new rail.
Yeah, new rails, right? Get rid of those V rail thingies and put legitimate linear bearings on there. That machine would be pretty solid. And while we're at it,
home switches.
I got the home switches. We just got to install them. But while we're at it, we should put those oh, you know what I need.
COMT roller.
New controller? No, the controller's in there. I got good controller. I have smooth stepper and everything. No need for controller. It's all good. Actually, standalone controller, so that it doesn't need to be connected to a PC, right? That'd be legit. But I do have that smooth stepper board that I put in there, and that's nice. The other thing I was going to say is the stepper motors, right? Those should be those new servos, right? Those techno servos, right? Yeah. You guys all know what we're talking about, right? I want to put these techno things on the 3D printer too. Actually, since Marty was showing me the
Cram Nitram Clear Path.
Clear Path. Yep. Technic. That's it. I said techno. Clear Path from Technic. Another super legit thing. Yeah, these things. Right? Little like self-tuning servos. You don't have to have like separate drivers and stuff for them. It's almost a drop-in replacement for a stepper motor. And what are they? $250 and up. So totally reasonable prices. And I could even throw these things on the chop saber. It's crossed my mind a couple times to upgrade the shop saber to servo machine, but that means replacing that controller. That's kind of like a bigger project that I want to get involved in, but it would be nice because when that thing loses a step, it's the most aggravating thing in the world. So, Marty, did you have any more comments about our little box here? I stopped over at Nitro to look for scrap material, and they don't have anything this big. It's too big. It's like 5 inches by 1.5 inches, right? So I gotta go on eBay and see if I can find somebody that's got a drop from the end of a bar that's the right size, so we can hog this thing out. We do have a challenge. I told the programmer over at Nitro that um, if he can't um, if he can't program this in 5 minutes, that they should fire him. And he said that I can't program it in 5 minutes. So
Cram nitram, how about extruded corners and just float top, bottom and sides?
can you explain a little bit more about what you mean, Marty? Are you talking about like just right here, like just that much? And then everything else flat stock? And a whole lot of silicone? Up. That way we get condensation inside? Not a bad idea though. Marty, you're on to something. Just extruded corners.
Cram nitram, I need to draw it for you.
You need to draw it for me. How do we do that? How do I get you to participate in the live stream? Is there some kind of app that we can do that? Can we do that in
Cram
Discord?
nitram, I had a project enclosure.
Project enclosure. You're making me think that maybe I can just make the, like you said, like TPU for the corners or something like that, and then just put aluminum sheets together. It'd be way easier than. Wait a minute. No, the easiest thing is going to like have somebody else run this on the Haas. That's gonna be the easiest thing to do. But I think we should have a race. Save this file in Mastercam. And I don't know. Let's see how fast I can get this thing going. What do I want? That's what I'm looking for. Okay. Of course, this isn't our final piece yet, but now just to prove a point, let's export this guy. Give me a step file from it. Oh. Don't have anything highlighted when you do that operation. All right, over to master. Let's bring that in. We're on the timer now, right? Stream folder. 5 enclosure step. Top view, right view. Just gotta get rotated. Rotate. Move 90 degrees. Oh, not that way. This way? Yep. There we go. Our top view should be good. Yep. Oh, there we go. Okay. Let's move this over. I need an origin somewhere out there. Snap to? No. Okay. Trim. There we go. That'll be our origin. Transform, move to origin. Right there. Okay. Now 0, 0 is at the corner of our box there. And I know our stock size, so our stock setup. Put the origin over in that corner of the material. Our 5 inches by 12 inches by inch and a half. Actually, let's say we're going to start with like inch and 5/8 material. And I'm going to have to move my part down a bit. Transform, translate, move in Z. How much? I don't know. 1. Oh, not Z. This one. I. What's this doing? 0. I feel like that's moving it. Oh. Okay. Good. All right, so now it's below. Now I can face top of that. Okay. Cool. Tool paths. Let's face this thing. Ugh. Already. That's what's gonna slow me down. Select all these lines. I'm gonna select a bunch of tools that I don't have. It's 5 inches wide. Let's say. Oh, 3-inch face mill. That'd be great. My machine can't handle that. Yeah, we know. Alright, one way. Sure. Overlap. Lots of overlap. 75. This is a rigid machine. Wait, across the lawn. Fine. Stock. Right to the final cut. And retract. Feed plane. Top of stock. Depth. Depth here. There. Yes. What's that look like? Perfect. Let's see if it's working. Go, faced off. Okay, next operation. Need a pocket. I'm not gonna do 2D high speed. Surface high speed. Try this one first. Loop. Oh, nope. I know. I want the other one. I know why. Surface high speed. Drive surface. This guy. Selected. Yep. inside. I don't know. Normally, would you walk around the outside first?
Maybe. Anyways.
Let's see. We're gonna hog that out with a half inch should be half inch, but I want
A radius on the
tip
like
30.
add some extra cuts in there. There we go. Let's see what that do.
Okay. Oh, that's way too much. All right, defaults are way too mild. Okay, let's get into this thing. Step over. 80% step over.
Where's our
Step down. Half. Is that gonna be our best strategy for a lot of volume? No, let's 3/4 of an inch, but 30% of the 30% of the tool. Okay. Stock to leave. I'm gonna go all the way to the floor. And this is the inside of a box.
We don't need to finish pass or anything like that. We're good.
Ram it home. There we go. That's much less.
Let's see
How fast that is.
That's not the right window.
No.
We'll see
How fast this is.
2
2 hours. What this one? How fast is this one? 3 minutes.
That doesn't seem right.
I think the defaults for all these tools are all jacked up. How fast are we moving here? Way too slow. Way too slow. How fast can you advance? Oh, it's yelling at me because my machine can't handle it. Whatever. I want to go 6 thou per tooth.
And for
You
we need to go a lot
faster.
than
Whatever it's
telling me here.
here.
Let's edit this tool.
Or flute. Oh, it thinks it's steel. Let's go carbide.
2
Thou per tooth.
Let's take that
Up to 4. Oh, oh my gosh.
What have I done?
I appear to have reset something. I made the tool faster.
Back to this nonsense. Going deep. There we go.
All right, let's see how she is. Now, we're not 2 hours, we're 6 minutes. That's more like it. like. Beautiful. Oh, cutter can't get through there. Oh, ooh. Is that bothering anybody? Not bothering me. Darn it. All right, that's fine. We can do. I would actually think that if I move those standoffs down in the model to allow the half-inch cutter to go through there, that would be the smartest thing to do. Not change our tool and spend a whole lot of time with a tiny tool. Okay. And I need to drill a hole. Drill. Select my points. There. A hole there. 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 Drill. Tool. M3. Anybody want to take a stab at what the proper drill is for an M3? Refer to my handy calculator here. Okay. Reference. Listeners, US. Nope, metric. Can you guys see that on the webcam? Not. 3. 2.4 millimeter. Half millimeters. All right. Now we gotta convert 2.4 millimeter to English. Drill sizes. All drills. 2.4 millimeter is close to 3/30 seconds or a 41. 41. All right, let's go with 3/30 seconds. That's more common. Okay. What's a good feed rate for that? 8, 10, 10. Go with 10. Okay. Our clearance over the part at the beginning and the end. And our retract is incremental. Top of stock is now down here. And our depth is down there. 0. Drilling operation. Let's kind of take a look at it. Take a peek. What do we got? 8 seconds of drilling. Beautiful. Our rapids are a little slow. Drill. Coming over. This probably should be a pecking operation, right? When I say a pecking operation, you would just take small little, like it sounds, take little pecks in order to break the chip and not clog that those tiny flutes up. But I'm going to accept that. And then our final, nope, not our final operation, but our next operation would be to tap those. So again, I'm going to drill. Starting with this drill operation. Select those. And I don't have the ability to tap, so let's say thread mill. Sure. We don't have treadmills in here, do we? Mutual. Treadmills in here. Tap. Treadmill. This. Undefined. Have to draw it by hand. Oh, who wants to do that at 11 o'clock at night? All right. Forget the tapping operation. We're pretty good. What would our final? Let's see. Our last one should be. Let's pretend that's a good tapping operation. And then we're just going to go and break all these edges with contour. Okay. So this is going to be our chamfer edges. Run around again with like a spot drill or something to break these edges. Tool. Spot drill. Quarter spot drill. Feed rate 30. Chamfer. Let's see, 20. 30. I lead in and lead out. Depth up there. 0, 0, 0. There we go. There's our chamfer. Let's play the whole thing back. All right, was that 5 minutes? I said I could program in 5 minutes. I don't think that was 5 minutes. That was probably more like 20, right? I'll post out the code and tell them it's good and ask them to run it. I'm sure it's fine.
Fail.
Fail? What do you mean fail? Oh, I didn't do the outside. Contour to the outside. Oh, shame on me. I missed the operation. Anyways. That's not too bad. Were you keeping time, Mark? I think that's not too bad. I don't do it every day for a living, right? All right. That's one of my next projects, is making this box. Marty and I got to get these timers done.
Tulsalence, I stopped the timer after
23 minutes. Please. There's no way that took 23 minutes. I'm going to have to watch the playback tomorrow. Nope. Okay. So, chat. Anything else going on? It's 11 o'clock. That's 2 hours in. I'm pretty good. Everybody got to see the molds being made for the King of Hearts booties. Else for tonight, I would say start thinking about what we should do for our next project. Let that King of Hearts quad is getting wrapped up. Start thinking about what our next quad should be. We've got our like sub 250 racer. Where do we go from there? Are we going like X class? Are we doing freestyle? maybe like a 6-inch build. 6-inch build that's made to carry 2 GoPros or GoPro Fusion.
Quest_FPV X class.
X class. I don't think that's going to be the only vote for X class. I think a couple people would like to see that. I have all the electronics for
Tulsalance X
X
class.
class.
I want to see some more molded stuff though.
More molding stuff. I'm sure I could do some really great fail videos on trying to make this aluminum box on my Shop Saber CNC. Those might be some really good fail videos because
Fender X
the
class,
aluminum
you
is
just
gonna
need to
fail
pretend it's
spectacular.
2015.
X class, you just need to pretend it's 2015. Fender. Easy Fender. X class is the new stretched X or whatever was popular last year. I don't know. True X. Is True X already come and gone now? Top speed. Let's see if we could do 200 miles an hour and beat that other guy. I don't know. There's a lot of things we could do. So everybody in chat, you guys think about what we should do for our next one. I'm not really that tired tonight.
Fender, yeah, but the motors and whatnot people run on X class are about that age.
Ah, that's true. The motors that I have are from 2015. That would be correct. That would be a correct statement there. We were even talking about just putting DJI NASAs in our X classes.
Tulsalance Freestyle X class.
Freestyle X class. You would suggest that. That sounds like a wonderful idea. We'll go down to the concrete jungle with our Freestyle X class drones. How big is it? X class is an X class 1,000 millimeter. Is that what we're talking about? What's the spec? Are there actual specs for it? I don't even know. I consider X class anything to be stupidly big. I've got to jump in assembly and see just how big this is.
Fender 14 or 15-inch props.
I've got to set up electronics for 15-inch.
Tulsalance frame sizes are limited to 800 mm to 1200 mm motor to motor diagonally at the aircraft's widest point.
Oh, you would have it all.
Quest_FPV, I had a 680 mm Hex X class built and sold it. Too much money in it to crash it.
Yep, that's what we're gonna do. That's exactly what's going to happen. Mark and I are going to take up our X-Class racers and we're going to piece them on the first flight and destroy $200 worth of propellers. Just like how I destroyed like $100 worth of propellers at Flight Fest last year trying to make the NLFPV hurdle fly, and we kept breaking props, and so then we put really expensive carbon fiber props on there because that's all we had left. We broke those. It was great, good times.
Fender just run APCs, they're like $10 a piece.
Yeah, 15-inch APCs. Okay, I'm down with that. That would save. What if we could just use, what if we can run Inspire props? Let's just steal the props off the Inspire and put those on their X-Class racers. That's 1,000 millimeter. So we got our prop, which is 15 inches. Is that right? I typed in 15 inches? Ah. a lot bigger props on it. 1,000 millimeters.
Tulsalans, you need to do 1,200 millimeters. Go big or go home.
Woo! Well, I say, what does APC have? Let's see. Their multi-rotor props aren't going to be that big.
Quest_FPV, call it the Flying Dutchman. Quest_FPV and let Mark fly it. Tulsalans, the Flying Deadman. Fender 15x 5.5 or so.
Oh, look at that. $10, 16s, 15, 16, 18s. Is there a maximum prop size for X class? No, we have a maximum prop size. Our motors can't do that. Our motors can't turn an 18. Our motors are only going to be good for 15s. Otherwise, we're going to be buying new motors, and then we're going to be in that same situation where it's too much money to crash.
Not that I see.
So let's stay with the 15s. That way we don't have to buy new motors. Alright, so we do 15s. And you said the minimum size was 800? Okay, so it'd be a quad like about that big. Now the other thing is, are we stretched? Which way do we want to go?
Fender, you need those motors that BM Sweb had in his T-motor video. They were about the size of your head.
Oh. Like those are the motors that they're like flying people around with, right? Yeah, that would be awesome. That would be really
cool. Stretch with a body.
Stretch with a body. Stretched which way? Long or wide? Long or wide, chat? Like long and narrow or wide and short?
Tulsalans Quest style. Fender a touch long.
Something like that. Bring something in for scale. Let's go out to the network here. Find some parts. This folder for parts here. Ooh, an Alex Moss. Remember those days, Mark? Remember those days? Alex Moss 8-bit brushless gimbal.
Tulsalans, put it next to the King of Hearts.
Oh, yeah. Good idea. These are our Vulcan parts, man. Vulcan power board. I was expecting motors in here. Where are the motors? I can't see these parts.
Fender, if you could tune those gimbals, you were pro.
Yeah. Tell me about it. Tell me about it. Having sitting in the dirt with a laptop plugged into a gigantic killer drone with a $30,000 camera hanging from it. The gimbal freaking out because your PID tune wasn't dead nuts on Ridiculous those days. I'm thinking the NASA flight controller in manual mode is kind of the way to go on these big ones, rather than screwing around with like beta flight, which doesn't like it.
That's one.
Fender flight test did the vector.
Fully defined.
Float. Okay. Attach
This would be like 6S build because we've got 390 kV motors.
that. I believe is what that just said.
Multi-star 390 kV. No. What motor is this? This isn't the motor we had. This is on my endurance quad. I've got a quad that'll fly for an hour and a half.
I think
This is the motor it uses.
I must have
Another motor
in here.
a bigger one.
Let's see. Everyone can see all
My parts in here.
uh,
Yeah, I've got 17-inch props on that endurance build. And it runs 4-cell. Those 390 kV motors.
and she
Can scoot around for like an hour and a half in the sky. Run missions and stuff. All the stuff that we used to play with before before our group got together. Need to get all that stuff out again. U8. That's
that's a
monster.
you don't need that.
Maybe in the motors folder.
Doot, 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 doot.
My motors folder
Down
here.
Motors. Let's see. What we
Got. Everything's tiny. Where the hell are all these bigger motors? Yeah, where's all the motors from that picture? I have them on
I have them somewhere.
just in this folder. Oh, I'm so disorganized here. Let's keep this to SolidWorks. Ooh, here we go. Here's some bigger motors. There we go. U3s. Gimbal motors. These U3s will work. That's like the right size motor. There we go. Wait.
Position.
Okay, so that is
Our motor.
our
And if we
drop our King of Hearts.
in here,
How big are we talking? Sweet. That's gonna be awesome.
Set up our motors here. Okay, there we go. Our motors.
And then we would have like a ridiculous body, right? I mean, like ridiculous. What's been rattling around in my brain is a large vertical fin as the body in the center. And so when you're flying at like 45 degrees, that fin would be vertical.
Let's draw that up
Quick.
and show you guys what's rattling
Around in my noggin here. There's no sense it staying in my brain. Like
that. That's I'm thinking that it'll exist in this space like this. Just
ridiculous big fin. I'm just drawing a rectangle that's kind of like a bounding box for how big I want it.
just ridiculous. Yeah, big
Giant.
flying fin, bigger. Maybe not that big. Maybe like that. Yeah.
All right. I drew that sketch just as like a guide.
So that
I could bail out of this assembly. That sketch would come with it.
let's
Save
this
this
as
our
my
stream
class.
class. Part.
And I'm just gonna
Start a new sketch on that. Wait, sketch.
something more
Like
let's see if this works. Grab a spline.
spline.
Go from
There with a spline. Spline is like a curve. Right?
So I can do that. Yeah, we can make this thing have some
Tangency. Yes.
no.
Not perpendicular. I don't know if this thing's gonna look silly or what, but try.
Yeah, that'll do. Okay, so
So I'm gonna make 3 curves in order to like form our volume here. So I need to make a couple more planes. Plane there. Oop. Okay. Also have a spline on it. So I think I can set it perpendicular and that'll be tangent. Okay, that's there. And one more plane. Over here. And one more spline. Set up our tangents here. Work on our shape. Okay. Yep. Okay. Let's see if I can make a skin out of this. So I'm gonna make a surface. Insert surface. Is this gonna be a sweep? I don't like doing it when it's I don't know. Let's just try sweep with a guide curve U. No. Ain't happening. Let's see. About like this. Nope. Nope. Not accepting. A loft. This is my profile, and this are my guide curves. No, it won't do that either. Oh, I hate when it's 3 lines and not 4. Quest, bail me out here. I don't think a boundary surface is going to do what I want it to do. Oh, maybe it will. Oop. Okay. We're on the right track here. Oh, boundary did do what I wanted it to do. Excellent. All right, there's our skin. Now I just need to start mirroring it a few times. Okay, this plane, this surface, face, body.
Quest_FPV, there you go.
We got there, right? Mirror again. Crossed. This. Okay. one more mirror
across our right plane.
all of that. There we go. Let's clean this up so I can see
What the heck I'm doing.
and stitch these all together.
Surface.
Knit. Knit, 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 knit. And try to form a solid. Sweet, it's a solid.
And we
Confirm that by slicing
it.
and it
is indeed solid.
sweet. That's what I want to see flying through the air. How ridiculous would that be? That'd be ridiculously awesome. Think about it. We'll paint that up, put some hot graphics on it. Nice big sponsor logos all over it. I think we can make that stupid thing even bigger than that. I don't think it's funny enough yet. We can really get carried away, can't we? Make that big enough. This is gonna be a sweet project. I like it. We're gonna have to cut this out of foam. This is gonna be straight out of the model shop over at Fisher Price.
Creme
cut
de
this
creme,
thing
I
out of
could
a
have made that infusion
huge
with
piece of
T-splines
foam.
in a quarter of that time.
Marty.
Wonder, well, that's not 2015 with 2 paint sticks.
Marty. I know that. Everybody knows that. In fact, that is the main reason that I use Fusion, is to use the T-splines. Yeah. That's exactly how this came to be. Boom.
Quest_FPV, they could do it, that's for sure.
Yeah. So this guy was basically took the mesh that that AI software kicks out. It doesn't give you a solid model, it gives you was it an STL? I think it was an STL. So it gives you a wireframe model. And I brought the wireframe into Fusion and then used the T-splines in order to make a solid model out of the wireframe. So yes, I love T-splines as well. But as much as I love the T-splines, they are fast. They don't have the same precision, right? Like, if we want to, we can actually get the curvature and everything on these things perfect. Right? Right, Marty? Right? In an attempt to like do Class A surfaces and stuff like that, as if we worked for like one of the major automotive companies. Right? Make sure all of our reflections are nice and pretty. Can I do that? Can I turn on the curvature and stuff like that? Oh, look at that. Ooh, look at that big nasty point right there. That's bad. Look at that. The curvature changes right there along the seam. Yep. No good. I fail. I failed design school there. Where's the zebra stripes? They work on this video card? Nope. Can't turn the zebra stripes on. Arms. So I don't want to go out straight with an arm, because I think that is going to make this difficult to fabricate. What I actually want to do is build prop guards into this thing, because I think that's one thing that X-Class is kind of missing, is prop guards. If I were in charge of organizing X-Class, I would have them enclosed, because that'll make things a tiny bit safer when you're talking about God knows how much these things weigh when they're done. But I know how much the Vulcan weighs, and I know how much horsepower the Vulcan has, and that's in the same like size range, right? The Vulcan's 8 motors, and that's 12 horsepower. So kind of looking at 6 horsepower in one of these guys, 4 motors. That's pretty up there into like murder your friend territory if you have an accident. So I don't know. I'd like to see him in a big enclosed prop deal. Let's draw that. Okay, right.
I'm still
Going. Enjoying myself.
here. You guys are sticking with me.
Although my brain's slowing down here.
Okay. So
This would be our prop guard.
which
Again, is like going to be a molded part, right? Cut this out of foam, paint it up, and then make a tool from it, and like do some fiberglassing. We're going to go old school, right back around. We're going to get all the
Quest
airplane guys
FPV
that know
would
how to
look
do
like
vacuum
just a
bagging.
giant tiny hoop.
It is. You're right. It is good. No, not quite. Not quite a giant tiny whoop. Not quite. I think maybe you're right. Maybe it will be giant tiny whoop. I don't know. The thing that I have pictured in my head, not tiny whoop, but it might end up being tiny whoop.
let's see.
I draw my like prop circle, so 15.5 plus a quarter of an inch on the tip.
Maybe that should be 16. Yeah. Okay. Wayne. We're gonna come over and
Fender tiny whoops seal the air to the ducts to a certain extent. I was think more like what was on the original Baby Hawk.
Alright, this might actually be where
fusion would come in really, really handy.
anyway.
I'm gonna do a couple splines here. Yeah.
2.
3.
Okay.
Perpendicular.
Weird. Oh, of course that's doing something really
Stupid there. That's gonna have to be
perpendicular.
the other way.
Okay. Oh, come on. Ridiculous. Ah, there we go. This has like no weight at all, right? That weight in there. Okay. Now let's try. Right. And then
We're gonna
spin that guy
around.
Don't have an axis.
There.
There we go. Cool. There.
This is gonna be sweet.
like add that to our mirror features.
Fender, have you flown anything ducked like that on anything bigger than a tiny hoop?
Nope. That's a no, Fender. I'm thinking that a 1/2 of an inch margin from the prop tip to the duct might help because we're not gonna seal it tightly to it. I don't know. Right? I don't know. Or do you like actually put the prop like into a channel in the duct in order to like fill that tip vortex? I don't know. This is way beyond me. Okay, clearly this thing is not comically big enough for our X class. I mean, we're just talking about sheets of foam that we can fabricate. We can do whatever we want here. We can be crazy. Clearly, this is not big enough. I think that this should have 2 cameras, a flight camera and a landing camera to be safe. Kind of like our bomber. Some of our bombers had multiple cameras with the switch. Probably a good way to go operate these safely. Let's see. I want to get my sketches. Make them bigger. Attached to the sketch, so making that bigger will make the whole thing bigger. Did got a little deformed, a little wonky.
Quest_FPV just landed in a beanbag chair.
This thing's gonna need like a big giant rescue net. Big like trampoline made out of net. Just disarm a couple feet above it and let it drop in. I don't know why I don't have teams across there. I made mistakes in my drawing, clearly. Clearly. This, that's where my problem is. That should be a much nicer form. Yeah. Hmm. So anyway, I'm thinking, okay, so if the body grows enough to actually touch the duct, that's how we're gonna like attach, right? But rather than running an arm over here, because the difficulty of fabricating all these like crazy curves, we run like just a tube from this motor to this motor, right? So run 2 tubes. So this would be like an more of an H setup. I think that would be the smarter way to go. Maybe this way? No. This way look cooler. Even though the drag would probably be better that way. Actually, because we stretched it, this is a longer tube now. So economically, we'd be better off doing the short tube. All right, so we do short tube straight across here. That's kind of our attachment. Take a tube across and then reduce the diameter of the tube and go over and hit the like outside of our duct. Oops, sorry, I'm drawing behind my camera. Yeah, so we take a tube like straight across here. That's our structure. Little King of Hearts. And there's our X class. And the King of Hearts can sit on the X class and go for a ride. Alright, holy cow, it's almost midnight. Alright, everyone's got to get some sleep. We've got work to do. Let's save this. And we'll work on that next week. And hopefully build our build our King of Hearts and do some modeling on the X class. Hey, what's the name of our X class, guys? What did I see go by? I'm trying to recall. Rolling up. Flying Dutchman. We need a twist on that, though. Right. Hold the chat. I guess that's it for tonight. Thanks for sticking around, guys, for a little extra overtime tonight. We'll catch you this weekend. Race number 6, 5, 6. I don't know. We have a few left over at the Boston track. I'll be there Saturday, from 4 o'clock till whenever, sometime after dark, because the track gets really fun after the sun goes down and the fog machine gets turned on. That's when that track is really fun. So I'm gonna be playing around there Sunday. I think my kids are available now, so hopefully we'll be over there flying soon. See if he can catch up to Benny Mac. I don't know. Nobody else seems to be able to, so I don't know. Maybe he can. Although Red October is getting pretty darn close. So close, right? All he needs to do is take out a little mistake here and there, and then look out. Might have somebody that's ready to dethrone Benny Mac. I don't know. You need to see Quest. His little hybrid brushless. Oh, that's a little too big for the Boston track. I don't know. The tiny whoops are good signs in there. Anyways, I'm rambling. I'll catch you guys over the weekend. All right.